Welcome, I'm Kevin King. In this, the fifth of our series of 6 in-road training videos, I'll explain how to conduct initial field runs. As with all our in-row videos, we assume that you're already familiar with setting up and running inter-row machines. If you are not, you would probably benefit from watching the inter-row videos first. In this video, we'll go through making final checks and setting off on your initial runs. Having set the machine up as described in the previous training video, it's a good idea to do some final checks before putting the machine down into the crop. Measure the crop row width and within the row plant spacing in the field and check they match the figures in your selected configuration. Also check that an appropriate crop height is selected. Check disc size entered in the selected configuration matches discs fitted and that they are appropriate for the crop. Disc size is the first part of the disc's part number and should be stamped on the disc. If you are running either reciprocating blades or nozzles, you need to check the plant zone distance that defines the buffer zone around the crop plants. Rotors will be given an automatic check on startup, but it's a good idea to do a quick check that other devices such as levelling and steering work normally. In-row weeding machines are inter-row implements with an in-row weeding capability added. It's much simpler to check the inter-row performance independently before adding with in-row devices. To minimise crop damage, remove or raise out of work anything that might cause crop damage. It does not matter if initial running is done running inter or in-row software, as both store camera skew and fine offset learn parameters in the same place. Place the implement down and move forward just enough to settle it at normal working level. Check for a good template match and that all rows are being tracked to the bottom of the image. Set off slowly as described in the inter-row training presentations. So, having established good inter-row guidance, now is the time to change to in-row mode. Fit one set of in-row cultivators or discs and set above soil level so that timing can be observed. If you have nozzles fitted, fill the tank with clean water. Place the implement down so that the first plant to be treated is in the top 2/3 of the image. Check that a blue-green cross has been placed on each crop plant. Move forward slowly, checking that the blue-green crosses continue to track the plants, while observing timing of the treatment devices relative to the plants. It is very likely that you'll need to make small adjustments to timing using fine offset up and down arrow keys. If you are running rotors and they are cultivating ahead of the plants like this, press the down arrow keys to move the green dot down. If they are cultivating behind the plants like this, press the up arrow keys to move the green dot up. When they are correctly in phase, it will look like this. If the machine has multiple cameras, you will need to repeat the procedure for each camera in turn. Once you are satisfied timing is correct on all cameras, you can add the remaining rotors and set them for shallow cultivation. Speed can be increased to suit the application with a maximum of 3 plants per second for hydraulic rotors and 5 plants per second for electric rotors. In practice, soil conditions normally restrict speed to 3 plants per second. There should be no change of timing as speed increases, as this video of an electrically driven rotor running above ground demonstrates. For reciprocating blades, the procedure is very similar. If they are cultivating ahead of the plants like this, press the down arrow keys. If they are cultivating behind the plants like this, press the up arrow keys. When they are correctly in phase, it will look like this. If reciprocation speed is fixed and forward speed varies, then cultivated area will be reduced as forward speed increases, as illustrated in this simulation. In the field it's not normally obvious as blades are hidden under the soil surface. It follows then that for best weeding efficacy, forward speed should be low in relation to reciprocation speed. It is possible to at least partially compensate for changes in offset due to time delays. But for maximum precision, we would recommend operating reciprocating blades at a fixed speed. When you increase plant zone, you increase the distance between the point the valve is activated and deactivated symmetrically around the plant centre. Plant zone adjustment is accessible via the setup page on the console. If plant zone is close to or greater than the plant spacing, the reciprocating blades will not reach between the plants, and so only inter-row cultivation is achieved. For nozzle fine offset adjustment, the procedure is very similar, and for the purposes of the following animations, we will assume that we are spraying the crop. If they are spraying ahead of the plants, like this, press the down arrow keys. If they are spraying behind the plants like this, press the up arrow keys. When they are correctly in phase, it will look like this. Nozzles can be configured in the setup page to either spray just crop plants and nothing else, as depicted here, or to avoid the crop and to spray just between crop plants, as seen on this slide. Plant zone can be adjusted in the same way as for reciprocating blades, allowing you to get further or closer to plants. Once all the devices are timed correctly, you'll probably find that the fine offset values are not central. It is good practice to leave the customer with these at least close to zero, so they have scope for adjustment in the future. Lateral fine offset can be neutralised in the usual way, as described in the inter-row training material. Fore and aft fine offset can be neutralised in two ways. You can either physically move the camera fore and aft in relation to the cultivators or nozzles, or you can edit the offsets in the configuration. First, we'll consider the physical adjustment. It is a good idea to think of the camera and the crop as a fixed datum, and decide which way you want to move the cultivators or nozzles to neutralise the applied offset. If the fine offset is forward, shown as upward and positive in the fine offset graphic, you would want to move the treatment devices forward closer to the camera. In practice, of course, it's usually easier to move the camera, so for a positive fine offset, you would instead move the camera backwards by the same amount. For example, if an applied fine offset of plus 3 cm, the camera must be moved backwards by 3 cm. Similarly, if the applied fine offset was negative, you would move the camera forward. Note that it is important that all other aspects of camera alignment are maintained, and that this forwards and backwards movement is a pure translation. Now we will consider the alternative of changing the camera distance ahead of cultivators or nozzles figure in the configuration to have the same effect, but without the need for physical adjustment. To take the same example, to neutralise a 3 cm positive fine offset, you should add 3 cm to the distance ahead of rotors figure. You can think of this as correcting for the fact that the treatment devices seem to be further behind the camera than previously thought during the initial setup. You are correcting for that error rather than physically moving the cultivators. Similarly, if the offset is negative, decrease the distance ahead of rotors figure by 3 cm. If you have multiple cameras, you should repeat this procedure for each camera in turn. We hope that you have found this presentation useful. Remember that it's the 5th of a series of 6 videos that you can select from our website and view them as many times as you want. Our website also has links to other reference and training material. If you have any questions, please get in touch. Thanks for watching.